Hey everyone, this is part 2 of our section 6.3 video series. So we're going to go back to the random generator, and so you're going to click on the link for the Rossmann Chance applet and then go to the random number generator page, and so I'll show you how to do that. So we'll click on this and it opens the applet collection, and so you're going to go to the one that says random number generator. So it's under probability menu on the right hand side, is the bottom one there. So click on random number generator and it brings up this screen. And so just going back to the notes, right? So this is what you want it to look like. So number of replications 1, numbers per replication is 10. We're picking 10 words. And the number range we're going to pick from 1 to 297 because the lyrics to the song have 297 words. So that's what we're considering our population, is the entire number of words in the lyrics to Beyonce's song. So 1 to 297, and make sure that it has no replacement, and then generate. So let's go back to the applet and put those numbers in. So we have 1, 10, so from 1 to 297 without replacement, and then sort the results, no, and then click generate. And then that's going to give you a set of numbers. And so write those numbers down in your notes. And so for me, when I did it, these are the numbers that I had gotten. And so there should be 10 numbers, and then you go back to the sampling frame and then look up those numbers. So for example, the word 191, when I go to my sampling frame, that's going to be the word thought. So here we are looking back at the sampling frame. So the word 191 is thought, and so you just correlate the number to the word and then write them down in your notes. So write my word 250th word is do, and so on. Notice that the 200th word is I. And so now, because this is generated by a random number generator, it gives me really truly random words that I'm choosing. Right before, when I had my own bias about looking for the meaning of the song, I would have never picked the word I as a word that is representative of the song. But knowing now what I'm looking for, that I'm looking at the length of each word, now this is a more random sample. And then do the number of letters. Does it contain the letter E? And then do the results again. And then once you have that, go back and put in your results in the Beyonce survey number 2. So I will update this notes once I have your survey results in, and I'll do the dot plots in StatCrunch and share the data with you. And so again, just to go through with the lesson today, I'm going to use the data from my in-person class. And so once we did it with the random number generator, notice that now the mean of the sample means was a lot closer to our population mean. The population mean is 3.59, and this was our mean here. So it approximates it better. It is closer to the 3.59, and when we do it again in StatCrunch, so once I put in your information from your class's survey results, I'll share the data from StatCrunch and I'll update these notes and reshare them with you. So, but for my in-person class, the new average was 3.3, so the mean of the sample means was 3.3. Now remember, before we had 4.66, so really high, and now 3.3 is very close to the population parameter, 3.59. And with the standard deviation of 0.58 when I did it in StatCrunch. So how does the answer from part B compare to the population parameter? 3.63 is a lot closer to 3.59. And so now let's go back to the question in part 10. See if I can get to it. It had asked, based on your samples, do we have good evidence that Beyonce did not write the lyrics to Crazy in Love? Now remember that the average word length for the songs that she wrote while she was in Destiny's Child was 3.64 letters long. So now, based on our new sample, do we have good evidence that Beyonce did not write the lyrics? So now our new average is 3.63, which is very close to the population per 3.59 and really close to the 3.64, which is Beyonce's average word length. So we would say no, we still don't have evidence. We don't have evidence against that she didn't write the songs, right? It's looking more like she did write the songs. While this doesn't prove it, we just can say that we don't have evidence that she didn't write the songs. Essentially, our analysis is showing more like she did write the songs, although, right, this doesn't prove that she wrote the songs. It's just that it is more likely that she did. So that's what this study is telling us. So in summary, when we are sampling from a finite population, so in this case the 297 words in the lyrics of Crazy in Love, we can consider the parameter to be a numerical summary of the variable in the population, so the average word length. With quantitative variables, we will denote the population mean with mu, and with categorical variables, we will often denote the population with the letter pi. If these values were computed about the sample data, they will be statistics, and this should be x bar, and then p hat will be our sample statistics. So we have essentially sample parameters, mu and pi, and we have sample statistics, or sorry, population parameters, mu and pi, and then sample statistics, x bar and p hat. So in our example here for this section, the parameter was the mean, 3.59 letters, for just Crazy in Love. Another parameter is the standard deviation, which was 1.60 letters, representing how far the word lengths tend to fall from the mean. One statistic here is the average of your 10 words, the x bar. So your particular x bar is a statistic. And then we found the mean of the sample means. And different samples provide different values for the statistic, right? Every one of you had a different sample mean because you had different 10 words, different sample of 10 words. And so that is what we call the random sampling error. And then let's see, we also talk about another parameter of the proportion is the proportion of all words that have the letter E. So in this case, for the Crazy in Love lyrics, there were 90 words out of the 297 that had the letter E. So the population proportion is 0.30. Now, in my set of 10 words, my proportion was 0.4, so I was fairly close to 0.3. So I encourage you to look at your set of words, your original sample of 10 words. How close were you to 0.3? And then what about the random sampling? Once we did the number generator, how close were you to 0.3 for the proportion that had the letter E? A sampling method is biased if the results from different samples consistently over or underestimate the population parameter of interest. So going back to the original dot plot, the one that was not a random sample, the one that was biased, right? Because we were, one of the reasons we said it was chosen this way is we were kind of thinking about the meaning of the song and how we were choosing words. So we had our own bias in there. So notice how the mean is here was 4.66. Now our population parameter, right, is 3.59. So somewhere around here. So we're consistently overestimating, like way overestimating, or underestimating the parameter. The parameter is the 3.59. And so that's how you know that your sample is biased. If you're consistently overestimating, so in this case I keep saying over because it looks like there are more overestimates than underestimates. But if you're consistently overestimating or underestimating, that means that there is some bias. Now when we did with the number generator, and we look at that dot plot, notice how everything is very much close to the population parameter is 3.59. So there's not a huge overestimate or underestimate. Everything is pretty centered around there. And so this is more an example of a simple random sample. So we don't have huge overestimations of the parameter. So that's what this part is saying. Now the reason that I chose this example and using the population as the words of crazy in love is because then I know I can find the population parameter, right? The average word length was 3.59. Normally we won't have the actual value of the parameter. Like example I mentioned in the first video was if I wanted to make a prediction or say something about community college students in the US, right? There's no way that I can get the entire community college population of the US, the parameter, the average of something or the proportion of something. But if I consistently take simple random samples and that are not biased, right, I don't overestimate or underestimate, then I should be really close to the population parameter. And so this is a big idea because it helps us, taking enough simple random samples can help us predict the population parameter, knowing that as long as they are simple random samples, they are going to be consistently around the population parameter. So going back to that dot plot, right? Here we are not too far away from the true mean of 3.59. And so that is kind of what we want with a simple random sample. And so when we take enough of them, we're going to be very, very close to the population parameter, even if we don't know what the population parameter is. So it gives us a good approximation, right? So in this case, my mean was 3.63, which is not too far from the population parameter. And so that is the key idea. So the statistics are unbiased estimators for a corresponding parameter whenever we use simple random sampling. Alright, so let's go on to section 6.4. So my next video will be on that section and how to use Z-scores and how to find the particular probabilities.